Good morning, everyone. Welcome. Welcome to the session. Very warm greetings from Mercy Technologies. So, we have been into our fourth class of our linked list. To be precise, maybe fifth class in our linked list. So, we have been coding on this linked list for quite some time this week. Yesterday we have seen a problem. We saw how do we solve that in brute force, and then how do we improve that code. That by number of steps that we can conclude that by taking two pointers we can achieve a better solution, right? So today we'll be continuing on the problem solving in linked list. So let's say what is our agenda for today. I told you yesterday that we'll be introduced to lead code, and I'll be teaching you about the intersection point detection in linked list. Then reverse of a linked list. Reverse of a linked list can be done either in a recursive way or in an iterative way. First, we'll be seeing how do we do that in iterative way. Then I'll be telling you how do we use recursion. We'll be solving two problems in recursion. One is printing the reverse of the linked list, and the second is actually reversing the linked list. And we'll be doing the time and space complexity analysis for all the problems that we'll be doing today, right? So without wasting any time, let's straight away jump into our Eclipse and start coding, right? Today, guys, I'll make you introduce you to this. What is that? One second. So lead code. Okay, you're able to see lead code over here, right? I mean, this is what it is, right? This is the URL for lead code. I'll be providing that to you in notes. So similar to HackerRank, for example, our problem is given over here, and we have to write some code over here, and we have to submit that, and we have to run the code, etc., etc. So similarly, I wanted to introduce you to lead code because I felt that the problem and the description and the way we have to solve, or the look and feel for these, is better in lead code than in HackerRank, right? So guys, let's try to solve a particular problem and make sure we are able to run all the test cases, right? So intersection of two linked lists. Let me try to open up the whiteboard and teach you what exactly it is. Okay. Let's say we have linked list something like this. We have linked list something like this. Okay. So what is it saying? So it is 1, 2, 3, 4, and let's say 5, right? So this is the head, and these are the links that are joining to all the linked lists, right? This is coming and joining something like this. This is like this. This is like this, and finally this is coming, and we are making that as null, right? This is null. So what I want to say over here is there is a linked list something like this. So for example, let's say we have one more head. Which is starting somewhat like this, right? We have one more head which is starting somewhat like this, and we are saying the value in here is 100, right? And here is also head. This is the start of a linked list, and what is the next that is pointing it? The next of this is pointing it to a node something like this. So if something like this is happening, then what we can understand, or what we can conclude, is there are two different heads. Let's say this is head 1 and this is head 2, right? There are two different heads. They are starting, and finally at one particular point, let's say this is the particular point. At this particular point, this both linked lists are converging, right? This both linked lists are converging at a particular point. So our requirement for today is we need to find what is this point, right? So this is a very famous interview question. This seems a bit hard by seeing just the problem statement or something like that. But let's try to solve this step by step. I mean, we will do that step by step, and so that we can derive or we can achieve the base cases, and we can start actually the coding, right? So let's try to do. How do we do that? How do we do that? Let's try to do that, right? So if I take so which means my program should be having two heads, right? My program should be having two heads. First head is this, and the second head is this. Okay, so what should I do as a layman, or maybe first before I start to write the code? So I should think, okay, if I iterate from head 1 until this null, if I iterate from head 2 until this null, at a particular point called 3, at a particular point called 3, this head 1 and head 2 in a particular point called 3 are converging, means they are becoming equal. So which means I need to find something like that. For example, let's say if I take one of my linked list is something like this, right? One of my linked list is something like this, right? So it is doing it is having something like this, and finally the other linked list is something like this, D E F, right? So if the example is something like this is head 1 and this is head 2. So what I can say, the intersection is point is not there. The reason is because this both are not equal, or this both are not having any common node, right? Any common node. So if we take this kind of an example, we should be in a position to say there is no intersection point at all. There is no intersection point at all. So for this, let's try to find out what exactly we can do. So what exactly we can do? First thing is, let's say I'm taking this head 1, and maybe I'll start iterating. And at the same time, I'll be doing the same thing with head 2 as well. I'll be start iterating. At a particular point, maybe I'll try to find out if the same, for example, let's say our P is somewhere over here, and our for example, let's say Q is somewhere over here. When P dot next is equal to Q dot next, P dot next is equal to Q dot next, which means they are coming. P dot next, Q dot next is this, P dot next is this. Somewhere in my program I need to write, if P dot next is equal to Q dot next, if that equality is there, then you return the intersection point, which means either you return P dot next or Q dot next, right? But here a particular point that we need to observe is, for example, let's say we start iterating from one loop and we start iterating for other loop. How do we make sure that two loops are in sync, right? Two loops are in sync. For example, let's say I start iterating from over here. I have a while loop over here. I'm trying to write something, right? In this only, I'm trying to do this P dot next, again the Q dot next. So these two things I've been doing. But when I do these two kind of things, when I do these two things, so what happens? My P will somewhere start over here, which is with the head 1, and my Q will somewhere start up. My P actually will somewhere start over here, which is head 1, and Q will start somewhere over here, which is head 2. And while I try to iterate somewhere at this particular point, after my first iteration, my P will become this, and then my Q will become this. Again, I'll be checking P dot next and Q dot next. So which means again my Q will become at this. So after my first iteration, instead of this, my Q will become this, which means even when I check P is equal to Q, it will never be equal, right? So then at this particular point, we are correct that we need to iterate it, but there should be some more logic we need to add, so that we can actually find out the intersection point. So I will straight away show you the code, and maybe make you understand what exactly we are trying to do, right? So here we are, the intersection point. It's a simple code, guys. Okay, so this is a simple code. I've written a lead code over here. So here, let's say we start with our base condition. What is our base condition? If either the linked list 1, which is head 1, head A, or head B is equal to null. So I told you, okay, before we go into the actual method, let's try to analyze the base condition. here I've written a method name called get intersection node, right? Get intersection node. Just by seeing this method, I'm able to find out what actually I'm trying to write in this method. So I'll be having two parameters, which is head A and head B. So these two are the heads. And finally, we should return a node. What is that node? That node is exactly the intersection point of head A and head B. In case if there is no intersection point, you should be returning null, right? You should be returning null. So this is the base condition. Let's say base condition, what is it saying? If head A is equal to null or head B is equal to null, if any one of them is null, which means there will never be an intersection point, right? Which will never be an intersection point. So that's why in this base condition, I'm returning null. So let's say, what am I doing as part of my step one? As part of my step one, I'm saying get the length of the first linked list and second linked list. So what am I doing? I'm trying to get the length of two linked lists, right? So we already have written a method called get length. So just a duplicate. I have written this method again, guys. I've written this method again. So what we are trying to do as part of our get length method, we are having some variable called length. In our previous program, we have taken a variable called count, and we are iterating it. Finally, we are incrementing that count and we are returning, right? Here, as part of my step one, I'm getting the length of first and second nodes, right? I'm getting the first and second nodes. So if we observe, guys, what is the reason for us to get the length, right? Let me go back here. What is the reason for us to get the length? What is the reason for us to get the length? We have sensed a problem something like this. Let's say we iterate, or let's say we find we have taken p over here and q over here, and we start iterating in our while loop. But at a particular point, p dot next will become q, and q dot next will become 3, and 3 is an intersection point. But the problem here is, even though our p is at particular number, which is 2, our q is at 3, we cannot equate them. We cannot say is p is equal to q, even though when we are at an intersection point. The reason is there is a change of length, right? There is a change of length before. There is a change of length here. If you see the length until this particular point, is, before that it is 2. So before this it is only 1. So let's say we have written a code somewhat like we should start iterating not from here, but we should start iterating from here, which is 2. We should start iterating from 2. When we do that, 2 dot next is equal to 3, and this 100 dot next is equal to 3. So in that way, when we come to the next pointer, we will be having a number that we can equate, right? This is the reason we need to find the difference of the length. So by finding the difference of the length and making sure that we are starting to iterate from that particular node, we will be in a position to come back to this point and making sure we are finding the equality of the node. Same thing I have done in this code as well. What I did, I have taken two heads. I tried finding the length of the both. Fine. So after that, after finding the length of the both, what I did, I said we should never modify our head directly. So I have taken two reference variables named p and q, which is head A and head B. And what am I trying to do? I'm making sure that the difference of the two things, the difference of the two linked list is now converged, right? I'll be dry running the same code, guys. I'll be telling you that. Okay, here I'm trying to increment my p until a particular point, right? After that, again I have written a while loop. These two while loops are only for the similar kind of a purpose. I'll be showing that to you why I have written that in our dry running. Finally, at the step 3, I told you we should start iterating. P is not equal to q, then we should say p is equal to p dot next, q is equal to q dot next, right? We should be doing this particular thing. Equality we are checking at this particular point, right? And finally we are returning p. This is a simple code, but let me try to dry run this for you and make you understand what exactly we try to do here. This is a bigger one, so I'm going to Notepad and I'm doing that for you. Okay, I have already taken that. So let me take a screenshot for this. So this is our screenshot. Right, I'm copying this and I'm pasting that in my whiteboard. Here it is. So let's try to take a small example and try to understand what our code is actually doing. Right? So here it is. What is our small example? I told you this is our example. So we have taken something like this. One, just a second. 1, 2, right? And we have something like 3 and 4, right? We have something like this, and this is null. And here we have one more node, which is, let's say, 100. Okay, and now it is coming over here, and finally it's doing something like this. So as part of our code, what we have taken something like this, which is head 1. This is head 2. So what is head 1 and head 2? Or maybe I've taken it as sorry. I think I copied some other program. Let me copy our program now. What is our program? This is our program. Okay, so I'll take a screenshot again. Dry running the code is very important because that is how I have already written the code, so that the class time is not consumed more, guys. But how you have to do it is what I'm teaching you right now. Okay, so this is what it is. I went to the whiteboard. I'm removing this right now. Okay, pasted it here. This is our simple code. Here's what it is. Okay, so we try to do one thing. First thing is, we try to do, as part of line number 3, we try to see if it is coming under base condition. So as I'll use the same what you call the naming convention. This I'm calling it as head A, right? This I'm calling it as head B. So head A is pointing to 1, head B is pointing to 100. So here we are checking, as part of line number 3 and 4, if head A is null or head B is null. So if this is the case, then what we are trying to do, we are trying to return what? Null. But this base condition we are not coming into, right? This base condition we are not coming into. So that's why we are coming to one more step, which is step 1. So I'm trying to say length A and length B. I've taken two variables, length A and length B. So we have taken two variables, len A is equal to len B is equal to. These are the two variables. What is the length A? 1, 2, 3, 4, right? Length A is 4. What is length B? 1, 2, 3, right? This is the two variables we have initialized both. While length A is greater than length B, yes, it is correct. So it is coming inside. What? It is coming inside this for loop. But before that, we have taken two variables, right? Two variables P and Q. Okay, we have done with this step. Now we have taken two variables P and Q. So let me try to put those variables also. So what is P? P is this. And what is Q? Q is this. Okay, P is this and Q is this. So what we try to do, while length A is greater than length B, P is equal to P dot next. Length A is greater than length B, 4 is greater than 3. So what I did, P is equal to P dot next, right? So what I did, P is equal to P dot next. P is not this, but P is this actually. P is this actually. So then I tried doing this length A minus minus, which means I'm trying to make sure that length A is decreased, right? Length A is decreased. Length A is 3 now. Again, we came to this while loop condition. Length A is greater than length B. No, both are equal. So that's why this while loop is now gone. And now this while loop is never even applicable, because length A is not less than length B, because both are equal to 3 now. So this is also gone. Now we came to the step 3. Our P is at present over here. q is at present over here. And what we do is p is not equal to q. P is pointing to 2 and q is pointing to 3. Q is pointing to 100. So both are not equal. So both are not equal. So at this point, what I try to do, p is equal to p dot next and q is equal to q dot next. So now p's value will be something like this. P's value will be something like this. And what will be my q value? Q value will be something like this, right? P is something like this and q is something like this. So here again, I'm coming back to my while loop and checking p is not equal to q. But actually speaking, p and q are pointing to the same thing, which is 3, which means p is equal to q, right? P is equal to q. So that's why this while loop is also done. And now we are coming back. And what are we doing? We're trying to return p, right? We are trying to return p. So what is this? This is our intersection point, right? This is our intersection point. Let me try to run this program for you guys. This is simple. This may look at the first glance what we are trying to do, but if we do it step by step, we'll be able to achieve that. So let me run this code for you and try to make sure that, okay, fine, maybe I'll straight away run that to you in HackerRank, so that we need not write the main method again. So what is this? I told you that we'll be doing that as part of our lead code, right? Lead code. So let's try to understand what is the problem statement that they have given. Maybe I'm on the full screen. Yes. So what is the problem statement? They are actually explaining that in a better way. What they are saying, if there are two lists, A1, A2, C1, C2, C3, and there's one more list, B1, B2, B3, and finally it is converging at C1, and finally it is coming to the end. So as part of our example, our intersection point will become 8. And again, as part of our example, the intersection point will become 2, right? Here, again, there is one more example. There is no intersection point itself. And they are saying we should return a null, right? These are the 3 examples that they have given. And our code should pass this kind of an examples actually, right? So here they have written some notes. Let's try to read it one by one. If 2 linked lists have no intersection point, then return null. I told the same thing. This is one condition that we need to be aware of. We are even doing that because as part of our last line, we'll be returning p. So what will p become in our example, in our dry running? What will p become in our dry run? The p actually, for example, let's say there is no intersection point itself, we will be moving in this while loop at the end, finally we'll be coming to this null. Actually, you can take an example in dry run. So which means we are capturing this rule as well, right? This rule as well. And what is this? If linked list must contain their original structure after function returns. This is an important point, guys. I told you that there should be any modification. There shouldn't be any modifications to the head. So that is why we are taking some reference variables and we are trying to do something on that. We are never modifying the actual head, right? So you may assume that there are no cycles anywhere in the entire linked list. We have seen yesterday a cyclic, linked list, but here they are saying our logic will fail when there is a cycle. But here they are explicitly saying you can assume that there is no cycle at all, right? Cycle at all. So what will be the value? The value will be 1 to 10 power 9. So this is important because should you take an integer, should you take a long value, which value you have to take it. So this is important for those cases. And finally, your code should be running in order of 1 time complexity and order of 1 space complexity. So they are explicitly saying that you have to write code that is taking order of n complexity and nothing more than that, an order of 1 space complexity. This is very important, guys, because only when you have the basics of time complexity and space complexity, you will be able to write code something like this. That's why most companies ask kind of questions like this, because they are explicitly specifying what is the time and space complexity that they are expecting from you. So when you know the expectations, you can write code something like this, what we have written, right? So what I did, guys, I just took the code from here. I just copied the code from here, the one that we have dry run right now. I pasted it in our editor. So I'm using Java for now. And let's try to see. I'm running the code here in lead code for the first time. Right? So here's what it is. It is accepted. It is accepted as what it says. It is accepted as what it says, and maybe it has taken an input. Intersection point is 8, right? Intersection point, this is the first example, and they have taken the same example as well. So this is the example 8, and so these are the two arrays, or maybe the linked list that they have denoted, right? Maybe now I'll try to do this submission of the code. Here at the time of your submission, it is saying this, right? I don't know, maybe they have given some statistics as well. Runtime is 1 millisecond, faster than 98.80 Java online submissions, right? 98.80, which means many people have submitted the same code, but they have written that in different way. Maybe they took a stack, maybe they took something else. So which means you are able to do that in 1 millisecond, and you are able to do that in 98.8% better than any Java programmer around the world, guys. That's only because you were able to analyze the thing and finally able to write something, right? How many submissions for this? Maybe thousands of maybe lakhs of submissions will be there for this. But we should make sure that we are writing the code in a proper way, and we are following this time and space complexity conditions as well, right? At this particular point, guys, I just want to ask you if you understood. So let's go back again to our agenda. Our agenda is we have taken an introduction to LeetCode, and we have this intersection point is done. Now we have to deal with a reversing of a linked list, right? Reversing of a linked list, and if we are able to solve this reverse of a linked list, this I can say the most important problem in whole linked list syllabus, right? Let's try to do that step by step, so that it becomes easier, right? Put all your concentration right now, guys. So I'm trying to take this whiteboard again, right? I'm taking an example that I actually used in my code. Okay, what is the example? 28, 27, 26, 25, 27, 26, 25, right? The same thing. Let me try to do this. So this is the example. All concentration, guys. Okay, this is the example. Here's what it is, right? 28, 27, 26, 25, right? This is a simple linked list. Okay, let's say this is the head. Okay, and we are having the next pointer something like this. Okay, so I'm saying this is null, right? This is null. So now I should be in a position to reverse this linked list. So reverse this linked list. Let me try to write the reverse of a linked list, how that would seem to be. So reverse of a linked list will be something like this, right? 25, right? 26, 27, 28, right? So here it is. We are taking that as null. Okay, so this is head, right? Just by seeing we are able to say that this is the reverse of a linked list. It starts from 28, 27, 26, 25. Now we are saying 25, 26, 27, 28, right? We have reversed the actual linked list. Now if we observe, we can even write it in one more way. So what is that? We are actually, I mean, this is our actual understanding, the human understanding. Let's say we can even represent that in this way: 28, 27, 26, 25, right? So 26 and 25. Here, important point is our 28 should be, now after the reverse linked list, 28 should be pointing to null, right? Null, right? 27 should be pointing to 28. 26 should be pointing to 27, and 25 should be pointing to 26. And then, so what will this become? This becomes head. Agree? This becomes head. I mean, this is just a different way of representing the reverse of a linked list. So this is how a human tendency of thinking. If you want to reverse, you have to do something like this, right? So again, I'm trying to represent that in a different way so that you I mean we can program this in a better way. We can program this in a better way. So at this particular point, guys, at this particular point, what I try to do, I just try to reverse the pointers, right? This is a pointer and it is pointing to the reverse direction. This is one more pointer and this is pointing to the reverse direction, reverse direction, reverse direction, reverse direction. So it is pointing to the reverse direction. So which means we can do something like this, right? We can do something like this. We can do something like this. What is that? We can remove this and say this is the head. We can remove this and say this, right? We can remove this and say this, remove this and say this, right? Remove this and say this, and finally this becomes what? This becomes a head and this becomes a null. This is not our head right now, this is not our null right now. Actually speaking, we have represented that in our red color the way we think, and in the blue color just to say that it can be, I mean it's a better way, it's just a modifying of pointers. The same thing in my green color, what I did is in our input I tried to do the reverse of the links, a reverse of the links, right? Reverse of the links. I tried doing something like this. So how do we achieve this? This is our simple problem statement. This is a simple problem statement, but we should be having a way to achieve this. We should be having a way to achieve this. So how do we achieve this is, I told you in our initial days of our classes, there are two ways of solving an iterative, two ways of solving a problem. First thing is iterative, and the second thing is recursive. So we have solved these two kinds of problems, iterative problems and recursive problems. So for iterative and recursive, we have taken examples and we have solved two problems. First thing is factorial. Second thing is Fibonacci, right? So you should be able to grasp all those understandings right now. I mean, not exactly 100%, but you should be in a position to understand what is recursive and what is iterative, etc., etc., etc. So here, till now, finding the length, or maybe even the previous problem that we did everything with iterative way, guys. So we will be trying to do our reverse of a linked list in two ways. First thing is iterative. Okay, first thing is iterative, second thing is recursive, right? These two are important. Interviewer may ask you, give me the reverse of a linked list using an iterative approach or using a recursive approach. These two are also very important interview questions. So that's why let's try to deal these two as two different questions, and maybe we'll be trying to code everything. So guys, I see the time is 9:15 and 9:13 right now. So if time permits, I'll be going to the recursive, or maybe I'll try to complete the iterative part now, so that we'll be going to this recursive tomorrow. So with this understanding, let me try to move forward and try to code this, right? Try to code this. This is a very simple code. Again, I'm going over here. So here, let me try to the same example, take the same example again. So take the same example again. Here's what it is: 28, 27, 26, 25, right? This is our input, okay? This is our input. So we should make sure that our program should at finally be giving an output with the reversed links, this green color, with the reversed links. All right. So with this understanding, let me try to show you the code, so that the reason why we have written. So previously, guys, in our previous examples, so what I told you is, so we should be taking examples and trying to solve that. We should be taking examples and trying to solve that, right? So let's try to take a small example, only a single code, only a single node. If head is null, so what will the reverse become? Reverse also will become null, right? This is one base case. Second base case is, let's say we have only these two nodes, 28 and 27. What should happen for this? Let's say 28 right? And then 27, right? 28 and 27. The output should be something like this: 28, 27, right? So there should be a link like this, not like this, but there should be a link like this. And finally, this should become to null, and this will become our head, right? This will become our head. How do we do that? How do we do that? We can do that in a simple way. For example, let's say we are trying to iterate, we are moving in this condition, this is our input, we are trying to move in this direction. So what we can say is we can take some temporary variables. So what are those temporary variables? Maybe let's say I take two temporary variables, p and q, and I have one more temporary variable. So these two are null right now. Okay, these two are null right now. And finally, I'm saying I have a temporary variable called r. I'm pointing to this particular number, which is 28. So what am I trying to do? As part of my first iteration, I'll say r is equal to r dot next. So let's say r is coming here. And now what is this? P is equal to, oh, maybe I'll straight away jump into the code so that it becomes even better and even clear for you. Okay, instead of writing those diagrams, I will straight away show you the code. The section point, reverse, yeah. So here, guys, so what I did as part of my base condition, I checked if it is null. If it is null, then there's no point of reversing. So I'm returning it directly. So what I've taken 3 pointers here. The reason for taking 3 pointers we'll be coming to know as part of our dry running, right? As part of our dry running. So these are the 3 pointers. I'm checking while r is not equal to null, I'm checking p is equal to q, q is equal to r is equal to r dot next, q is equal to q dot next, right? We'll try to dry run this code and find exactly and try to see if we are able to solve this problem or not. Fine, let me take a screenshot for this and try to make you understand that in a better way, right? So I'm taking a screenshot for this. 1 second. I'm taking a screenshot for this. I'm copying this, pasting it over here. Pasting it over here. Let me try to write the example again and we'll write on this code. So what is the example for us now? It is, let me put it over here so that becomes easier. So what is our example for today? Our example for today is 27, 26, 25, 24, right? This is pointing to null. This is pointing here, this is pointing here, this is pointing here. This is our head, right? This is our head. So when our head is somewhat over here, as part of our base condition 6 to 8, we are checking if head is equal to null. Head is equal to null? No. So this base condition is coming out. So what we are trying, we are taking 3 variables. We are taking 3 variables, right? I'm taking 3 variables. So what are those? P is one, Q is the other, right? And what is the other? R is the other. R is pointing to what? R is pointing to head, right? R is pointing to head. R is pointing to head. Both P and Q are what? Now these two are nulls, right? That's what we have initialized. These 3. So now while R is not equal to null, no, R is 27. So what you're saying, P is equal to Q, right? What is P? P is equal to what? Q. But Q is already null, so P will still be null, right? I'm again doing Q is equal to R. What is Q? What is Q now? Q is not null, but Q is somewhere over here, right? And again, R is equal to R dot next. R is equal to R dot next. R is not here, but R is over here. R is over here. And Q dot next is equal to P, right? Q dot next is equal to P. What is Q dot next? Q is this. Q dot next. What is P now? P is nothing but a null, right? P is nothing but null. P is nothing but null. So this is the actual thing after our first iteration. Let's come back again. Let's come back to our line number 12. You are again checking R is not equal to null. R is where? R is at 26. R is at 26. Now again we are doing the same thing. P is equal to Q. So what is P? What is P? P is not null now. P is what? P is equal to Q. So which means our P is somewhere over here. and q is equal to r. Now q is not here, but q is somewhere over here. And again, r is equal to r dot next. R is not here, but r is over here. And you're saying q dot next is equal to p. What is q? Q dot next. What is q dot next is equal to p. So which means something like this. Which means something like this, because p is pointing here. Again, we'll do the same thing. Again, we'll do the same thing. P is equal to q. Same thing. So what is this? Our p is coming over. P is not here, but p is over here. Sorry, p is over here. So, and then again we are saying q is equal to r. What is q here? Q is equal to r. Now q is not this, but q is this, right? Q is this. R is equal to r dot next. What is r? R is not this now. R is this, right? Q dot next is equal to p. What is q? Q and its next is p, right? We are doing something like this. Q dot next is equal to p. Now again we are coming back. Again we are coming back to our line number 12, which is the while loop. What we are trying to do, we are checking r is not equal to null. No, r is not equal to null. Again the same things. P is equal to q. P is not here, but p is over here. Q is equal to r. What is our q? Q is not here. Q is over here. And then r is equal to r dot next. R is not here. R is over here. It's pointing to null. And q dot next is equal to p. So what is our q dot next? Q dot next is p, right? Q dot next is equal to p. Again, we are going to line number 12 and checking r is not equal to null, but no, r is equal to null. So that's why our condition is now done and we are rejecting the condition. And what we are returning q, right? We are returning q. So when q we are returning internally or indirectly, we are saying now our head is q, which means our head is q. So somebody will give you the q as a pointer. It will say q dot next, that becomes 25, and then that next becomes 26, that next becomes 27. So indirectly here, if we are pointing here, we are pointing to null, right? Here we are pointing to null. So with this simple code, we are able to reverse the linked list and finally make sure our input is reversed. Same thing I'm opening up in my Eclipse. The same code, I just copied the screenshot and trying to run this program, guys. So when I try to run this program, I have taken an input something like this. At line number 28, what I'm doing, I'm traversing the linked list. I'm printing every element in the linked list. So as line number 29, what I did, I'm calling this method called reverse. So after I reverse, I get reverse linked list. Again, what I'm doing, I'm trying to iterate over linked list traversal and finally trying to print that. So let me run this program for you. What is this program saying? This is giving me an output something like this. The actual input is 28, 27, 26, 25, but the output, the reverse linked list, the output is 25, 26, 27, 28, right? This is how we are trying to reverse this linked list. Let me try to show that to you even in HackerRank as well. I'll be giving you this link, guys. I'll be giving you this link. The same code. I have not modified anything. The only thing that I modified is instead of having node, I made that a single linked list node. And I did the same thing, base condition. I've taken 3 pointers. I've written a small while loop. I'm making sure everything is working fine. I'm trying to return Q, right? There's nothing over here, maybe less than like 5-6 lines of code. Let me try to run this code for you now. So it should be running fine. There are 2 simple test cases and these 2 are running fine. Let me try to submit this code for you. So all the test cases would also be passed. In HackerRank, you do not get any statistics, but if you try to see our discussions and if you try to see that, that really confuses you a lot, because a lot of things happen in the in our discussions, and we may get lost, right? This is the test cases, guys. You can actually go through the test cases, what exactly they did, what is the expected output, are you able to write that, or are you able to get that, etc. So with this, guys, this is the explanation for reversing of a linked list, which is a very famous interview question, right? So at this point,